Hey guys, today I'm going to go over the thoracic ribcage, thoracic diaphragm, and a couple of the joints that attach to and around that region. So we're going to talk about, diving right into it, we're going to talk about the thoracic diaphragm and the pelvic diaphragm. There is a reciprocal relationship that occurs with these regions. Okay, so I have here a sketch. This is the right side, this is the left side, because we have two different sides to respect here. The thoracic diaphragm and then the pelvic diaphragm. This is the rib cage with no ribs drawn in, and this is the diaphragm that's right underneath and kind of within the rib cage itself, right? Because it's not just in the front, it's inside and deep to the whole torso. The pelvis, on the other hand, has a handful of pelvic muscles. Many times in women's health, it's referred to as the pelvic floor, but if you are human, we all have pelvic diaphragms. So what we have here is a pelvic diaphragm that houses several muscles, and what happens is there is a relationship that occurs with breathing. There's a lot of different things that also occur with respect to gait and how we walk and how we function. I'm pretty sure I could dive into a whole other kind of 30-minute or more video on that, but what I want to describe with this specifically is the relationship, what happens when we breathe. To use a specific model here, this is a rib cage. So this is a great tool to describe the relative motion of the rib cage. Okay, there's a couple different structures that we can understand that are not visible on this. There's the diaphragm that's right here underneath and within the region of the rib cage that helps to expand when we do our inhalation and then compress when we do our exhalation. The interesting parts here that are not kind of explicitly stated on this is the attachment sites of the diaphragm. There's a little bit more on the right versus the left, and there's a little bit more of an attachment from the right side going down on top of the lumbar vertebrae. So if I draw just a little bit more here, there's a little bit of different about, I believe it's called the crura, from the right versus left, and then it kind of intertwines with some of the organs and it kind of crosses underneath as well. So the reason why this is important is when we take an inhale, this happens. The lungs need to expand. So the lungs need to do this. So they need to, specifically, they need to go downwards and then also fill in a 3D manner. So we need to have some type of motion to allow for that. It's sort of a vacuum, if you will. There's a pressurized system where the diaphragm descends. The pelvic floor, pelvic diaphragm, it also descends. So it reciprocates whatever is happening. So if I had a pelvis model here, it would go downwards in relationship to the thoracic diaphragm as well. The other interesting part is when we start to walk and we start to move, if I'm standing in a certain stance, perhaps there can be a postural component involved as well, because the diaphragm is a postural muscle. It is not just a specific muscle for breathing, but that's also its function. So the thoracic diaphragm is a specific and a very unique muscle because it has two different functions within the body. It needs to do double the work. For example, we don't ask our biceps to breathe to help with pressure for an organ because all the bicep does is it flexes the elbow, all right, and then it eccentrically allows for this motion, extension of the elbow as well. So that's its only function. In this case, it allows for a postural stabilization of the lumbar vertebrae, as opposed to just being kind of at its own kind of devices. It's kind of maybe in an extended base position, right? Perhaps the diaphragm is not properly positioned. And then we have certain postures that arise out of that. With that being said, there are two functions of the thoracic and pelvic diaphragm. They're both stabilizers of posture, and then they also assist with the respiratory cycle. So those are two big things there, right? Because when we are in a different stance, so say I'm on my right leg, I have a right hemidiaphragm that's in a different position than my left hemidiaphragm. And then when I go to the other side, same thing. This left hemidiaphragm is in one position versus this right hemidiaphragm. All right, so as we begin to walk, run, sprint, jog, side shuffle, etc., we're going to be going through all of these movements very dynamically. Okay, we're not very static creatures. Otherwise, we'd just be paralyzed or in a stasis of sorts. So I think that takes care of that. There's a lot of other things that can occur within this. I do want to go into one other thing. I know I said I was done. There's one other item here to respect. The rib cage has a lot of different musculature, more than just the diaphragm. Breathing occurs more than just through the diaphragm. Meaning, at the same time, there's also this other phrase called belly breathing. It's gained a lot of traction for whatever reason. The simple kind of anecdote or phrase I have for that is there are no lungs in the belly, so therefore we cannot breathe through the belly. We have our intestines, we have other organs, we have stomach, a liver, 2 kidneys, so on and so forth. So it's not really belly breathing. Essentially what happens is there may be some facilitation of other musculature that will assist with breathing, certainly, in the belly region. But essentially what we need is we need to respect the fact that there are other muscles involved. It's not exactly just belly breathing. It's not just diaphragmatic breathing. There needs to be some mobility of the ribs. In between each of these ribs, there's intercostals. Right? There's 3 sets of intercostals. I believe it's internal, external, and then there's like an innermost phrase, if I'm correct. With this being said, there are intercostals that allow for this motion of these guys. So they can move and they can expand as they breathe, right? Not the fingers just expanding, but motion occurs in between the ribs, all right? And it's a front to the side to the back. So there's intercostals by the spine. All right, so with this being said, there should be some motion in several directions, and that's going to lead to the second thing here. All right, the second thing that we're going to look at is the thoracic rib cage. There's a pump handle and a bucket handle. So I already drew the first one here. So if I'm look, this is P, this is A, posterior, anterior. We're looking at this from the side. We have a bucket handle position. We have some red arrows here. Bucket handle means essentially it's old school buckets back in the day where there was some literal bucket handle where we would pump water. Meaning, if we start to move like this and we inhale and exhale, you're going to get this anterior and superior motion when you breathe. So we tend to get this rising. Okay, so that is not an incorrect mechanism. It's just what happens. So we have a pump handle action there. And this happens primarily through the upper rib cage. On the other hand, a bucket handle, if I could draw a super quick. So here's the manubrium, sternum, and we have the xiphoid, a little bit of a wing looking thing here. There you go, not bad. Bucket handle, all right, and we have our thoracic diaphragm with different crura, right? The bucket handle is this lateral motion that occurs with breathing. So we get this side-to-side motion that happens with breathing, okay? So all these things should occur. So we get this motion because of false ribs. False ribs are not attached to anything. They're attached to costal cartilage. So what we have is, all right, so inhale, they move. Exhale, they come down, all right? And then there's going to be all these different positions that come about with it, right? Some people are here on one side, some people are here on the other side, some people are like that, some people are forward. There's a lot of different positions that come about with bucket handle breathing, all right? So that describes what happens in this relationship of the rib cage. However, something that I don't see quite often is what did the ribs attach to, right? They attach to, and this is a great model for this specific one, specific reason, the ribs attach to the sternum. Right, there's a sternal attachment, and more specifically, the costal cartilage in the front attaches to the sternum. But this is not the best model for the back because it shows a one-to-one relationship of how the ribs attach to a thoracic vertebrae in this case. Right, if this is T1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, it shows a one-to-one relationship. That's not the case. So we have this. So what we have here, this is anterior, this is posterior. You know, if I just write T2, T3, and then we go all the way down to T12, what we have from T2 actually to T9, okay? If I draw all the way, and we just fill in the rest of the gaps, this is T9, right? There are double attachments, in meaning there are 2 attachments, a superior and an inferior facet for the ribs to attach to. So what we're getting is toward the posterior aspect of the vertebral body, right? If we're looking at this guy as the vertebral body, it's not just a one-to-one relationship, but it's a above the joint and below the joint, the vertebral joints is where I'm going with this. So what I'm trying to say is there is a thoracic rib component that attaches to the spinal vertebrae, which is important because it's not just breathing and then we just breathe and then we're better. what happens is the breathing component alters what happens at the spinal level, which is big. Because if we breathe in a specific manner, that means we can change how our spine moves. So it's not just about the ribs, and it's not just about certain angles of the ribs or the pelvis. But in reality, if we can change what the rib cage does, perhaps we can change what the spine does. And if we change what the spine does, well, we could do a lot of other things, right? We could do a lot of other actions, at least in the proximal manner. Okay, so where I'm going with this, right here, T2 has an inferior costovertebral facet. So right there. And then T3 has a superior costovertebral facet. One rib attaches to both sides. So one rib, in this case the second rib, or in my case, sorry, T1 will be up here, so the second rib will be right there. The third rib would attach to the inferior costovertebral facet of T2 and the superior costovertebral facet for T3, which means if we breathe in a certain way, right? Here's the first rib, here's the second rib, the one that I'm talking about. If we breathe in a certain way, we get this motion. What happens to the spine? Does it move in a certain direction? So it's not just something happening in the sternum. Something happens in the back as well, at the vertebral body. Now what happens if it's only done on one side? Then it gets a little tricky. So what I have here, I stole this trick from my one friend, Mike Zhao, very smart guy. So what we have is an analogy or a metaphor of sorts, right? What we have is a screw with some bolts. And I'm going to use my hand as the rib. So if there's this curved thing attached, and then these are the ribs, okay? So if we're looking at this, I'm going to hold the bottom screw relatively tight. We'll say that this is T2 and this is T3, just for argument's sake. So I take an inhale, and then I exhale. Take an inhale again. So what's happening to the rib? What's happening to this right here? Some movement is occurring. So if this is the anterior portion, this is the posterior portion, right, the one that's facing me, and I'm attached to the posterior part of the rib. As I inhale, the face of the screw or the bolt that is facing you, the nut rather, is rotating in that direction. So, and then as I exhale, what happens? If this superior anterior rib right here in the front, this guy right here, if it goes down as I exhale, where does the spine rotate? So I'm going to do it one more time. And then I exhale. And then we can now add that within the whole region, the whole chunk of the ribs. So first, second, third, fourth, so on and so forth. And what happens with those ribs? Because there are double attachments with respect to how they attach to vertebral bodies on the back. Where I'm going with all of this is there are more functions than just rib cage motion. There are more functions than just pelvic alignment. So where I'm also going with this is there is spinal motion that occurs. So nothing happens in isolation. When we breathe, we get this motion of the thoracic diaphragm. The pelvic floor, pelvic diaphragm also goes down, okay? What we also get is we get certain motions here from the inside. It rises. When we inhale, we also get this motion going laterally, side to side. All right, and then not just according to the certain rib cage motions, but we also get some spinal motion. All right, so if I'm holding this and I'm going to go, and then as I exhale, so I'm getting relative motion of the spinal vertebral body as I breathe as well. So I hope you found this video helpful. I'll post again something when I find something useful to say.